Hey everybody, this is Larry. This is me over Q4 of the bi-weekly contest 133, count the number of inversions. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one, it's a bit tricky, honestly. A little bit of a post-mortem or retrospective first, as I always do on things that I'm not happy about, is that I'm really disappointed about myself on this one. I really mostly had the ideas down, but I came up with like a weird thing and I just kind of got a wrong answer. And worse of that is that I took 40 minutes almost to solve this problem for whatever reason. Even though I had most of the idea kind of in my way, but I also misunderstood some part of this. Or like I wasn't sure. I think I just misunderstood some part of this in my head, even though I read the problem correctly. I misunderstood some part of this. Okay, the key thing I would say is that no spoilers. The way that I would think about it is that you don't have to look at the constraints, right? N is equal to 300, count sub I is less than 400. This lends itself to a dynamic programming solution. I also kind of was a little bit struggling with this part because the way that I initially thought about it, it could be, n squared times count, which is going to be like 36 million or something like this when I plugged it in, which seems a little bit slow, but and it is a little bit slow. It's just that you have to mind read Leetcode, because when I test one of the, not quite the worst case but close to the worst case, maybe it is the worst case actually. When I tested that, it took 2 seconds, right? So that means that if you give me 5 max case or whatever like this, Python would time out. But it's hard to guess, and that's why I kind of struggling a little bit and had to YOLO and guessed a little bit. It does actually submit correctly, but like I said, there's no confidence in it, so it's just a very weird mind show. But okay, so the key thing to know about this one is figure out the state, and I kind of messed this up for a while, but I'm going to bring up the drawing board real quick. Yeah, the idea about the state is, the key thing to know about the state is that every index can be selected independently of each other. It may not be obvious initially, and this part I actually did realize very early on, so it makes it worse that I didn't get the other parts, whatever, right? So let's say you have n is equal to 5, so that means that you have, I forget if it's 0 index, but it doesn't really matter if it's 0 index or not for this particular one. But so then now let's say the last number has a 2 inversion, right? Well, what does that mean? What that means is that okay, actually let me explain this another way first, because I want to kind of show a property, which is that let's say the last number is 2, right? You have, what does this mean, right? Or maybe more importantly, yeah, how many inversions does this have so far? Well, the thing is that we know that in these numbers, there's going to be 0, 1, 3, and 4, right? And in this case, that means that there are 2 numbers that are greater and 2 numbers that are less than, right? So that means that here, by choosing 2, you used up, if you want to call it that, inversion of 2, right? That means that no matter what happens to the rest of this, there is going to be a 2 inversion, right? At this spot. In the, like, it doesn't really, like, it, yeah, it's just that there are 2 inversions, right? Because the rest of it doesn't matter. And you can think of, and if this is, the same space, just give another example. If this is a 1, there are 3 numbers that are bigger than that, right? So that means that there are 3 inversions to the left that you use up, right? So that's the first observation. The second observation is that now, let's say we do the 1 case, right? We have 0, 2, 3, 4, and then now you have to figure out how to do just 4 spaces into this thing. But the thing, of course, is that so we have to do 2, 3, 4 in some 0, 2, 3, 4 in some way. But the key observation here is that, well, why not just renormalize it, right? So now instead of this, we renormalize it to 0, 1, 2, 3, because nothing to the right of it matters anymore, right? It just matters to the left. So then now again, in the new number, if we choose, say, the 2 again, then now there are only 1 numbers to the left that are smaller, so then now it uses up 1 inversion, and so forth, dot, dot, dot. So there are 2, maybe I go a little fast, I don't know, but let me know in the comments. But so, okay, so let's reiterate the two observations that we need to make this, one is that on the last, index, we can count the number of inversions it contributes to, and then the second one is that, excuse me. The second one is that we can renormalize, reindex everything, and not have to worry about things that we already processed. So a combination of these two things. As a result of the combination of these two things, it allows us to create a state, right? And that's basically the key idea behind this problem. And this is how we do our dynamic programming. I'm not going to go over dynamic programming too much in this particular video, just because, I want to keep this video focused on the ideas, all right? But yeah. But basically, at first we go. This is Python. I actually rewrote this in Java using ChatGPT, and there's a funny story that if you watch the live version, you'll see in a little bit, but I'll also explain it or talk about it. Yeah, so lookup is just that so that we can look up the requirements in constant time. Pretty straightforward here. Here we're going backwards. So one thing I want to make a comment about is that going backwards, you don't need to go backwards. You can also go forward, right? There's some symmetry in that. The only thing that's a little bit different in how you do it is that because if you don't look at the future, then your limits are a little bit not as tight, I guess. The key thing is because that you're given the requirement of the last element. You're always given the requirement of the last element. This gives you a tight bound on how to memorize space and do a for loop. For example, if this is going backwards, right? So let's say the last requirement is 300, but you only have a 1, right? Count is 1 in the last element. Then this actually becomes much cheaper just because you don't because we have a for loop. I'll explain more later, but you have a for loop that doesn't go for the possibilities that are impossible, right? Because, for example, if you only have 1 inversion at the end, you're not going to put a 5 at the end, you're not going to put a 0 at the end because that is already too many inversions, and so forth. But if you're going forward, you have to, you can do it that way, but you have to figure out some crazy math, maybe, or just more structure and more pre-processing to do that. But if you go backwards, then now you could just count up to the count, right? And the way that I think about it is that we have two dimensions. Index is pretty straightforward. The index that we are processing, and left is just the number of inversions that we need to do, right? And I think one observation that I kind of messed up when I was looking initially is that the inversions are a sort of a prefix sum, right? You don't have to use it for the current index. And that's the part that I was a little bit confused about when reading this in my head. I'm not saying that the problem was unclear, it's just that I think I read it wrong in terms of this is the number of inversions that we need to do. We need to left to do, right? And one more observation here is that as a result of this, the inversions requirements should be monotonically decreasing, right? Because you can't have, because it's the sum of prefix of the inversions, you you can have like 5 inversions in the first 2 elements and then 1 inversion in the first 3 elements or whatever I said. I don't know, right? Like you cannot drop in inversions because it's just monotonically increasing. So because of those 2 properties, it gives a cheap-ish dynamic programming property. And beyond that, it is just kind of, I wouldn't say brute force, but just going through all the cases. And I definitely struggle with this. That's how I got a wrong answer, and it took 40 minutes. But and in fact, even in the 40 minutes, I kind of got it wrong, to be honest, which you can see later. But yeah, the base case is we have the last element, then either we don't have a requirement or we do have a requirement, it has to be 0. I guess I could have actually just, now that I think about it, I probably could have just done something like if lookup of, if 0 is in lookup and is greater than 0, we can return 0. Maybe that makes it a little bit faster, I'm curious. And more important than making it faster, though it doesn't feel very fast right now, is that then this becomes more easy to write because we know that this condition is true. So then we just write that. Yeah. But anyway, yeah. So let's basically it's saying that the first element has to have a 0 or doesn't exist, which it has to be a 0, right? And the reason is just because you can't have an inversion on 1 element. So if that's true and we have no inversions left, then we return 1. So this is actually much more straightforward. And then otherwise you return 0 because if you have inversions that you need to do, you haven't completed your job, so you return 0 because this doesn't count. Otherwise, if lookup is not an index, so that means that there's no requirements, or if there's a requirement, it has to be exact. So this is the only case. Otherwise, we return 0. Even though I wrote this in a weird thing, but yeah, you return 0 if there is a requirement and it is not the same, right? So maybe you can write, maybe this is more, maybe this is a more natural way of writing it because it's a more natural way of saying it, which is that if there is a requirement and we are not exactly the same, then we return 0. Otherwise, then it is just brute force in that way of keeping track of the number of inversions and also keeping track of the number of basically this is the last digit, right? If the last number is I, how many inversions did we use up, right? So this part is the use up part, and then here we just go from right to left, we just go 1 more to the left, and that's basically the idea. And you yeah, there's also this min thing where you go from, so you obviously you don't want to go higher than left, but also you can't go higher than index because index is the number of numbers that you can choose, right? So yeah, so that's basically the idea. And of course, remember to mod, remember to add, and that's pretty much it. Yeah, so what's the complexity here, right? Complexity index go from 0 to n, so that's, you know, left can go from 0 to 400. Or you can say maybe m is equal to max element in requirements, which is equal to 400 because of the constraint. And inside there's a for loop that's O of let's say n, because m is greater than n, maybe, I don't know, either way. So yeah, so there are O times m, n times m, total number of inputs, and each input takes O of n times, roughly speaking. So then the time complexity is O of n squared times m, which feels a little bit big, to be honest, but apparently works for Leetcode. Yeah, that's pretty much all I have. I want to check out the submission real quick of Yeah, it doesn't. It saves me like zero point 0.1 seconds adding that if statement, but I think it just makes adding this if statement. That's what I wanted to check on, but it does save me some time. But yeah, that's mostly all I have for the important parts. The interesting thing is that I actually, if you watch the live part, I actually try to go from left to right. So here, for the numbers that are left, I wrote n minus index or something like that for the numbers that are left. But because of this complexity, I didn't really trust it to be fast enough. So I actually resubmitted, or I asked ChatGPT, with the code looking something like this. I asked ChatGPT to convert this to Java, and it actually fixed it for me somehow. So the Java was correct, and you could see at the end that I had to come back. I was like, why is the Python not working? And I had to debug the Python code, and it turns out that ChatGPT fixed it for me by accident. But also, if that was actually what I intended, that would have been wrong. So I got a little bit lucky, but also ChatGPT, please don't change my code to something different. But yeah. Yeah, that's all I have for this one. It is amusing. ChatGPT actually saves me for once, but still, I'm like I said, I'm actually a little bit disappointed about this problem just on myself because I had most of these parts up in my head, but I think I just kind of didn't put it together. I blame it on not sleeping enough, so I don't know. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health, and you could watch me solve it live in the contest now. One right, so. All right. Okay, start. Let's finish this. An inversion account of each requirement. Okay. Mod. Okay. The order doesn't matter in the requirements, then, right? What is how do I read this? N is 2. Oh, it's like a prefix sum. N is 300. N sub I is equal to, oh, okay. Oh, I see, that makes sense. But I don't know why the 0 makes sense, but I guess that's fine. Oh no, I guess it makes sense. It makes, no, No, it doesn't make sense. It's just 0 elements. 0 will always be 0. Does it always have a 0? I don't know, that's very weird, but okay. This feels like a problem should know, but it's kind of tricky. No, fuse DP. How do I do DP? Someone already got it. These comments are kind of useless. I don't know what these inversions mean. 0, 2, 1, 2, that's true, but I think this one's just wrong. I think that's why. Yeah, I think this one's just, the comment is wrong, that's why I'm confused. This one's fine. How do I even write this? I don't know if people are getting it. I mean, this feels like a standard font, but I don't know it. No, we should sort it. Can you put force? Yeah, I guess this is just divide and conquer, right then? Is that true? So now it has to be bigger than X numbers. So you put force. Okay, let's say you put force. Oh no, that's, no, everything is forced because everything is already after it, right? So then now, how do we go back? There's no going back, you just do it. Yeah, okay, I think this makes sense. Yeah, actually this is pretty okay. Then, yeah, let's go, just don't confuse yourself. Out left. Oh, can you do left then? No, it has to be exact, right? So there's no choice. Okay, I'm just being dumb, I think. I think this is actually not that bad. I'm thinking of something else. Okay, then now, yeah, right, so otherwise, what is the if index, then we just okay, otherwise, this is the number of inversions, and that means that there are n numbers smaller than it, right? So that means that this is and you either off by 1 or something, it's fine, should be okay. So that means that if this is 2, then this is a 2, right? Yeah. That means that you have no, I think this, yeah. That's not right, but maybe it's a good try. 2, 2. Oh, did I mess this up? I did mess this up in the wrong order. Okay. Do I have to reverse it? I think I have to reverse it. So 0 is... Yeah, by symmetry, maybe I could just do this. Okay. Is this right there? Let's see. Was it 2, 2? Should be, is that 6? Two, 2 is 6. Oh, I guess, no, that's not right. Did I just get lucky on the thing? Alright. Maybe. I'm close, we should fix it. We should solve this, but no, they should. Okay, but why is this 6? This isn't 6, right? This is... well, that's not right either. We need to do is n minus 1. It's kind of right, but... oh, whoops. Why is this so long? 2, 2. There's not a lookup. Did I just get this? Nope. Why is this returning 0? Larry. And this is actually wrong, but... why is what? I have 2. 2. Okay. That's the number of choices. That's the inversion you need, right? So why is this wrong? Lookup index. And minus index is the numbers left. And minus index. Index is at 2. So you have one number left. No, that's not true. So okay. Am I right? No, because I think there's a weird case where it's just impossible. I mean, there are other weird cases where it's possible, but this is wrong, so okay. That's not right either. Okay. Do I mod everything enough? Yeah, it looks okay. Let's give it a YOLO submit. Why did I get that? How is that wrong? Maybe this is harder than I expected. Okay, well, this makes sense that it is wrong, but I'm just trying to figure out why I'm doing it wrong. Okay, so there's no degree of free. Oh, there's 0. I did not look. I messed this up, I think. Wow, a lot of people got it though. Yeah, I mean, this is definitely wrong. How do I enforce it? What does this mean? This means that the last number has to be a 2. Yeah, I don't know why I think this is right. Okay, because I was looking at these things and it works. But okay. It needs to be another variable. Because you can't just put anything, right? What's that now? I did it the other way. We have to count up, but I didn't do the math for counting down. I don't know. I mean, people know how to do this one, but maybe I have to rethink about it. Okay. What does this 0 later mean? It means that is it just max? Can you still have inversions later? Yes, okay. So that means that we have to do like a prefix thing, that's all. Okay, maybe. Okay. Oh. No, but I still do 0. Oh, well, now it's a little bit different. Oh, this is wrong. What is this case? Why is this return? Am I bad? I mean, yes. I'm just not thinking it through. 0, 2, 2. Oh, it doesn't have to be a 2, does it? It's just that. How do I write this? I mean, I'm just wrong in the way that I'm writing this. Yeah, I'm just wrong because it doesn't have to be on this index. Maybe it's a known problem, people know it, but it doesn't have to be on this index is why this is wrong. And I'm still trying to fit that in. Because, yeah, because this could, even the, it's technically, well, here is right, but if I do 1, I don't think the answer is not 2, because it is 0, it could be 0, 2, 1, 1, 2, no, I guess not, 1, 0, 2, maybe that is it, I don't know. Yeah, maybe that is it, but, It's okay, I know. It should be used. Okay, I think that's how. Use that's gonna be C. Yeah, okay, I am being dumb. Yeah, I'm being dumb. Okay, I got it. Okay. That's how I do it. Okay, I was not understanding the problem enough. This should be... You go to n minus used or something like this. So if it's 0, yeah. No, it's yeah, okay, left, right. So then now first one should always be 0, right? Yeah, I don't get it. Okay, fine. Otherwise, we have freedom. So we can choose any number. This is right, I think, actually. Maybe. Yeah. I am so bad at this. Why am I so bad at this? This is also wrong, but okay. This is what I needed. Why am I so bad at this? You used okay. Inversion, okay, yeah. And then otherwise, it's something like this. But yeah, look up some. But this isn't quite right either because we wanted. Okay, because. Okay, yeah. If. Well, making progress maybe? I don't know. I mean, it's straightforward except for this one. Y2. So this is right. Let me take up one. Oh, this is maybe just a little bit awkward actually. Two. So there's one inversion. So okay, so you have two. This isn't right then, because this can never give me two things, right? But it does give me. So it's set the biggest number. And I am just not getting this. Okay, maybe these two. What is this case then? I think this case is actually reasonable. So there's no choice, and you just go up to left number of views. Why is this wrong? Why is this giving me 3? 2. It's going 1 with This is going to be 3. So 1. Wait, so 2, 2. You have 1, 0, 1. Right. So we picked the biggest number, then now it's going to be 2. So it's going to be 1, 0. Or we picked 1, 1, right? Does 1, 1 give us a good answer? I don't think so. 1, 1 gives us one means that we have 1. But okay, so with force oh, this has to be, well, for sure, but I'm just not thinking right today. I have the idea. I think this is the right idea, but I'm just not thinking. Is it even, Larry? Is this the right idea? Because 300 times 300. This is 36 million. Okay, right. This isn't right. Okay, so we choose 0, there's 1 inversion, let's choose 1, there's 1 reversion, there's 2. The recurrence is right, then what am I wrong on? If there's no choice, then we just go up to left, or n minus index plus 1. Why am I? One is going to go to 0, 0. No, 0, 1. Somehow I left this. I meant to do it, but the way that we write it is actually going to be at least the right answers. Maybe. Okay. Maybe this times out though, I think, to be honest. We can try something like what is the math? This is not a great time. Though, like I said, you can never tell. Let me convert it. Yeah, it takes a while, but let's go to generate. 400 is out of bounds. Oh, is there a memo? Nope, is that length. Line 18. Oh, whoops. No, this is right. Maybe. Maybe this is wrong though. I think this is the right thing. So let's give it a submit. Maybe it's wrong. Maybe that's fine. Alright. That was dumb. I'm dumb. I mean, I should have gotten that one earlier, but I had the same idea, but I just kind of wasn't thinking about it. Oh, good job. Oh, well, Josh, Aryan, well, good props. Wow, that is longer than I expected. I'm curious whether Python works. May time out, so maybe that saved me 5 minutes, but huh. I just forget how. Did I what? Did I mess up? That's funny that the Python is wrong. How can it be wrong? Or like how can the Java one is right but not this one? That's funny. Yeah, just 2. Why am I returning 0? I actually don't know now. Now I have to debug it because that is funny. So I would have even wasted more time if I didn't have this. But, huh. I mean, it's fine, but like I'm curious. I am actually legitimately curious. I mean, this is different. The memorization is different, maybe. I mean, that's actually different. It's pretty bad that ChatGPT generates different code, though, actually. But that's not it. Huh. I'm actually very confused. Why it returns different code? Am I just like seeing things? Nope. So 6. I mean, I'll give people props. I want to debug this. I'm curious why. I mean, in a way, I got lucky, you know, and I don't appreciate it. What is different about this? I mean, the only thing that I changed was using long, but I don't think that's quite, you know, like that shouldn't matter in the way that like this is a little bit wrong, or not wrong, just this is a little bit different, but I don't anticipate that changing anything, and it doesn't. That is actually nuts. And I didn't really like do anything, I don't think. Why? The 1 and 0 maybe? Does that change the answer for me? Nope. Less than equal to 0? Did I do anything funky? No. Huh. Why? How? Tell me why. It's still 0. Am I just returning 0 for stuff? Okay. But why is this 0? This is wrong. Well, I mean, it's apparently right, but they converted wrong and into the right thing. Wow. That is funny. And also, yeah, that makes sense. I was thinking about the numbers left, but I got it wrong. So it would have been accepted, but wow, I got lucky. Wow. I mean, it just shows that I'm not thinking about this for some reason. Like I really should. Yeah, I don't know. I think I just kind of put it in there for the. Because, okay, the reason why I had it that way is because I initially went from 0 to n, right? But then when I went backwards, I didn't change it mentally. But Java, wow. I wonder if Java already knew how, like maybe Java. I don't know. It's just nuts to me. So I guess okay. So even this score is a little bit lucky. I don't know what to say about that. All right, let's give props. Josh for winning a contest, of course. Mad props to you, Josh. Welcome back, as people say. Iron 4th is very good. Yeah, I feel kind of bad about this. Well, because a lot of silly mistakes. And the first wrong answer was just that I misunderstood the problem, really, or like not the problem, like I understood the problem, but I misunderstood the observations. But also like I should have gotten this one very quickly. Like I had most of the idea, but I think I just kind of confused myself a lot. I think the observation that it was in my head, but I kind of missed, in a weird way, is this idea of like prefix sum-ish, meaning that the requirement should be monotonically decreasing, and I guess I didn't need to do it this way anyway. Yeah. I am cool. It's a very weird looking thing for sure. I am also, let's take a look at the submission time. I mean, I suspect the Java one is pretty okay, so I don't have to worry about it. Yeah, but internal error. Oh no, it's just probably because it was running. So okay, same time anyway. But yeah, so is this observation of like prefix things and then being used? I think I was just a little bit confused about some parts of it for whatever reason. I don't know. I just woke up. That's my excuse. I'm gonna go back to bed actually. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this explanation, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.